Following on from the previous video, it helps greatly if you can create a grid like this. So this here is your x-axis, this here is your y-axis, and this here is the origin. So when you have 2 points, capital A and capital B here, the coordinates at point capital A is at the origin, and the coordinates at point B is given by small a, comma B here. So try and understand what's going on here. We are trying to find the coordinates here where the snooker ball will settle. You see, the snooker ball will settle at the point where y will be at its lowest. So what's happening is that we are sliding x back and forth here. We are trying to find a location here where y will be at its minimum. So for example, if you make x to be very, very big, meaning if you hook the snooker ball right here, it would just y here will be quite high. So the snooker ball will just slide down here to a point where y will be at its lowest. So it will settle at a point where y will be its lowest. If you hook the snooker ball here, it will just slide down here to a point where y would be at its lowest. Okay, so we are trying to find out x and y here where y will be at its lowest. So what we're varying is x here. We're sliding x back and forth. But the thing is, when we do that, we have to keep the length of the string. Let's say the length of the string is, let's just say 12 whatever. Okay, 12. Let's just say it's 12 for the time being. We have to the snooker ball will move in such a way that the length of the string will always be 12. Okay, so imagine our total length of our string is 12. The snooker ball will move in such a way that the total length of the snooker ball will be 12. Well, if this distance here is x, then the length of the string from here to here will be given by this. Okay, because this here is x, the length here is y here. So using Pythagoras, this squared, square root it. This length here will be given by this. Okay. Well, if the coordinates of point, remember this here is point small a, capital A. This point here is capital B. This length here will be given by b minus x here. Okay, minus x here. So this length here is given by this, because you would just get b take away x here, take away this length here. That will then give you this. Okay, and this length here, this total length here, the whole total length here would be get b. Let's just imagine this length. So this point here, let's just imagine it is at negative 3 at the moment. Okay, so y at this point here, just imagine it's negative 3. Okay, so what is this total length here? Well, this total length here would be b, and then in this particular case it will be b minus negative 3 here. So you would then take this out, and then it will be b plus 3. Okay, so this total length here would be b minus y here. Okay, so just imagine this length here is negative 3. Then this whole length here would be b take away y. In this case, y is negative 3. Okay, but it's definitely a negative here. So this whole length here will be b minus y. Okay, so this part of the string here will be given by this, and this part of the string here will be given by this, because you've got to use Pythagoras here. This thing squared, that's this bit here, and then this thing squared, that's this bit here. Take the square root, and that will then give you this whole length here. Okay, so the whole length here, and this here is given by, well, this length here is given by this length here is given by this. So our constraint here is really this. You get this length, which is this, and then you add this length here, must always be some sort of must be the total length of our string. Okay. So hang on. So the constraint here is this thing plus this thing here must be the length of our string. So this thing plus this thing here must be the length of our string. Okay. We'll continue in the next video.